Determine the limit as x approaches 0 of x cubed times the sine of 4 divided by x squared. For the limit as x approaches 0 of x cubed times the sine of 4 divided by x squared, the first thing to do is plug a 0 in for each of the x's. That will give a 0 cubed times the sine of each term that is a constant divided by x to a positive power will go to positive or negative infinity as x approaches 0. 0 cubed is 0 times the sine of positive or negative infinity. The sine of positive or negative infinity is indeterminate due to oscillation, but it will stay finite somewhere between -1 and +1 for the sine function. Since it's multiplied by 0, this limit should exist and can be found using the squeeze theorem. We will start by putting the sine function, regardless of how strange its phase looks, it sits between -1 and +1 at the very most. Our function up here is x cubed times that, so we will now multiply each of these by x cubed. -1 times x cubed is -x cubed. X cubed times the sine of 4 divided by x squared. And then +1 times x cubed is x cubed. The inequality still holds true. And now we can take the limit as x approaches 0 for each of these. And the inequality will still hold true. The leftmost limit, we will start by plugging a 0 in for each of the x's, which will give a -0 cubed. The middle limit is the one we want to determine, and we will leave it alone. We can't determine due to what will become a sine of positive or negative infinity. The rightmost limit, we can plug a 0 in for each of the x's, which will give 0 cubed. 0 cubed is 0. The negative of 0 is also 0. Again, 0 cubed is 0. And now the middle limit is being squeezed between 0 and 0. Since it's between 0 and 0, due to the squeeze theorem, it has to also equal 0. So the limit as x approaches 0 of x cubed sine of 4 divided by x squared is equal to 0. And we have determined the limit and found it to be 0.